Hello, welcome back to Cracking the Cryptic and more Sudoku fun on a Saturday night. And we've got a puzzle called Yo Banana Boy by Danny Meckler, who's a first-time constructor. And that's a good tip for people who want to attract our attention. Give your puzzle an interesting title. I don't know what Yo Banana Boy means, and frankly, call me Banana Man. But I'm intrigued. And the puzzle looks quite interesting anyway. It has a slight twist on palindromes as a rule. We'll get to that in a moment. Don't forget our Patreon and Discord. Patreon channel is going fine. We have lots of new content, including in 3 days' time now, March, quite approachable Sudoku. There will be a contest. Do give it a try. We are expecting a lot of people to be able to enter it and get it right, and we think it's a fun one. Now, on Discord, of course, there's just constant chat going on all the time about everything, including some very excellent technical discussion about Sudoku. Some of the finest constructors in the world are very active there and very welcoming. It is a good place to go. Of course, there's also all our apps, and you can buy our merchandise and lots of other stuff on the links under the video. Sven's SUDOKU pad as well, where you can play lots of puzzles. Now, this puzzle's rules are these. Diagonals contain the digits 1 to 9 each, so not bad. Those are a set of the digits 1 to 9. We've got these clues showing the sums of diagonals, little killer clues. So those 2 digits add up to 15. These 5 add up to 26, and they can contain repeated numbers. And we've got these lines. Now, apparently these are 2-digit palindromes. So the lines are palindromes. They read the same forwards and backwards, and also they only contain 2 different digits. And the examples Danny's given are ABABA and ABBA. One of my favourite bands. So those are the rules. There's also a cage actually. So there's a 3-cell cage adding up to 9. So give it a try on the link under the video. I'm going to start now. Let's get cracking. How do we do? Okay, well, Danny's been kind enough to give us 4 given digits. And we don't always get those in puzzles these days. But 2 of them, moreover, are on the palindromes. So that 3 is the second digit from that end. It must also be the second digit from that end and must be there. The 1 must be on the end of that palindrome. And I think we can go further with the 1, because if there's only 2 digits on this palindrome, this one is obviously not the same as the one on the end. Those 2 are the same by the palindrome rule. And because that's the same, this one has to be the 1 again. So whatever this is not a 1, and that has to be a 1. So these 3 are all the same. That actually, let's use yellow if we're in a banana puzzle. This one's also got 3 that have to be the same, as does this one. I don't know if that really helps. You could go a bit colouring mad on this puzzle, because remember, red could be the same as purple, for instance, and I suspect none of these could be the same as each other apart from that, but that is something that can trip you up, so just be cautious. Now, what else have we got? We've got a 20 diagonal, and we've got a 9 cage, and they intersect. And that feels quite interesting. Oh no, hang on. We've got a 9 cage in a box in which we've already put a 1. So that's 2, 3, and 4. Now, the 20 diagonal could be, okay, I was going to say it could be 9, 8, and 3. But I've just spotted the other digit we've put in is a 3. And that's looking at that cell. It can't be a 2 because it's on this 20 and 3 cells. So that's a 4. And that's another palindrome digit. We can put in a 4 there. This is now, those 2 add up to 16, they're 9 and 7. That's on the end of one palindrome. Oh, look, and it can't be 9. So that one's 7. This is a 9. These 3 are 5, 6, and 8. Now, what's happened to this? It can't be 1, 7, 4, or 9 now. Oh, that's not that helpful. Oh, look at this little killer clue. This adds up to 19. 7, 11, 12. These two add up to 7, and they can't be 1, 6 because of the one already in the box. So they're either 2, 5, or 3, 4. But one of them is this purple cell, so that can't be 4. So we can take the 3, 4 possibility one way out, and this is 3 or 5 here. So that's quite a start. I like this. This is not unapproachable. 1 and 1 there. There is a 1 in one of these 3 cells, but it actually can't be here because that has to be the same as that cell. So 1 is restricted to one of 2 places there. 4 in the central column is in one of, oops, that's not what I was trying to do, in one of those 2. These are from 2, 6, 8. What else does that give us? Oh, let's not forget the diagonals. They're probably not going to be very helpful yet, but 7 and 1. It's often numbers that are off the diagonals that are more helpful than numbers that have actually gone on them, but we don't have much information about. Well, I suppose 5, 6, and 8 can't be on this diagonal here. So, I don't know, they're going to have to appear somewhere up here. Ah, this 15 is either 6, 9, or 8, 7, and that one can't be a 9 because of the given 9. Oh, this is now even, isn't it? 2, 4, 6, or 8, because all the odds have been used in the column. So all the reds are the same. Now, does that let us get into this diagonal? Yes, a bit. These can't be 8s, because they would add up to 16, plus the 9 is 25, and then 2 other cells would have to add up to 1, which we cannot do in a Sudoku context. So red isn't 8. Oh, we do now know that red isn't the same as purple because of the digits that we've got as candidates. So all the 4 colours I've highlighted, and I could have done more, but the ones I've done are definitely different digits, which might be useful. Now, where did we get to? We got to 8s. If these were 6s, 12, 21, these two would have to add up to 5. If they were 4s, they'd add up to 7. No, they'd add up to 9. And if they were 2s, they'd add up to 13. That's not actually all that helpful. They add up to 5, 9, or 13. Now, what about down here? These two are the same. 7 and 4 form a sort of warped X-wing there. They must, in row 7, appear in these 3 cells. So at least one of them is on this, maybe both of them, on this palindrome. It doesn't really tell me all that much. Yeah, I was going to think about this 31. The trouble is that's not very restricted. This could be high or low, and still the 31 could be achievable. It can't be 1 or 2, I reckon. But other than that, well, actually, it can't be, okay, it can't be 1 or 2 because of the diagonal. It can't be 3, 5, or 9 because those digits are all seen by a blue cell somewhere. So blue now is 4, 6, 7, or 8, and I might be missing something in one of those cases. I don't know. I don't think the intersection here is telling us much, so I need to find something else to go on. Okay, across the bottom, 2, 3, 4, 7. I don't know, that doesn't get anything done yet. Oh, I don't know where to get the next step for this puzzle. Right, oh, 3. 3 is ruled out of those cells by the 3s we have in the grid. So it's in one of these two and one of these 3. That's maybe not that thrilling. I think it can be there. Yeah, both of those will work. 1 is in one of these 2 cells. Yeah, I think it may be just regular Sudoku that gets us going again, but how are we going to use it? Here's a thought. If this was 6 and 9, where would they go on this diagonal? They couldn't go in box 3 on the diagonal. They'd have to be here and here. That's right, isn't it? I think that's right. And if they were there and there, this one, yellow would be the 6. This would be the 9. It is possible still. If they were 7, 8, we've already got 7 on the diagonal, then 8 will be in one of those, but I don't see how I can rule that out. So, okay, maybe there's something else thinking. I haven't really thought about this palindrome at all. Here's something to think about with this one. These 2 have to appear in these 3 cells because those will be the same. So that would be one of the digits from here, 2, 3, 5, 6, 7 or 8. That's not, okay, this might be better. Yes, look, these 2 digits, whatever they are, and they're the same, remember, they must appear in these 3 cells in column 3. So they're either 1, which they're not because they see a 1, or 4, 5, 6 or 8. I mean, it's not a huge advance, but it's definitely true. I don't know what I'm missing, Danny. What am I missing here? That pair adds up to 7. I don't know. I'm definitely not catching on to something, I feel. Is it these that have to be the same and are matched up there? I suppose so is red up there somewhere. This is a little, I've only just realised, this is a little 2 by 2 of the same digit. So they must appear in these 3 cells as well. And nowhere else in this row, in these 2 rows. No, I don't know what that's telling me. Right, just need to think a little harder then. 9 in this box is in one of these 3 cells. Oh, hang on, where's 9 on this diagonal? That might get... No, that was just because I saw it couldn't be in those 2. Yellow sees a 9 up there, so that can't be a 9. No, that's not an interesting question either. Right, come on, think about it. What's going on here? Is it these little killers? Am I failing to realise that they're incredibly helpful? If that was 4, 8, 15... You could have 2 8s. No, I just don't think that gets it done. Here's something exciting. 4 in column 5 is in one of those 2 cells. Now that cell, row 2, column 5, is the same as that one. So either that's a 4 or that's a 4 because of the column 5 restriction. That means there's no other 4 in row 3, and therefore this isn't a 4. Ooh, and now we're getting close to a triple or something. Well, actually, we've only got 2 places left for 4 in the column. And for 9, is that right? No, now where does 9 go in this column? I think it's a write-in. It can't be there because of that. It can't be there because it's the same as that, which sees a 9. And we've pencil marked all these to not include 9, so it must be here. And now 4 has to be here. Again, that can't be there. Well, because of that, I suppose. So we get the 4 as well. Wow, that's so strange. Now, what is yellow? It can't be 3 or 5 or 7 now. It sees all of those, as well as 4, 9 and 1. So it's 2, 6 or 8, I reckon. Another even digit. Strange that both yellow and red should be different even digits for some reason. Now, what else can we do when we've got this 4? What's that done? It's off that diagonal. So those are the only 2 places left for a 4 on the negative diagonal. Does that mean anything? Not to me. Probably missing something totally blatant now. Saw one of those comments yesterday saying, why when Simon and Mark see something, don't they just stop and work out what it means for other things? Well, we do try. It's just we're human. We don't spot everything. Now 6 and 9 would have to be here and here. Did I exhaust the point about 4 being in this row somewhere? Or maybe I can do that somewhere else. I can't see any other obvious places to pull the same trick. Now, these 2 were going to be the same, and we're either 2, 3, 5, 6, 7 or 8, but that's still a litany of numbers, and I can't narrow it down as far as I can see. 7s. Just one of these little killer clues must give me some traction. 3, 1, 4 and 4. So 4 has to be in one of those 2 cells. I mean, it's probably there. Oh, 3. 3 can't be in either of those cells. Oh no, I've done that already. If it's in one of those 2, it can be purple, of course. Quite likely it is purple. Oh, come on, Mark. Think it through. That one is 2, 4, 6 or 8 for the column. That's almost giving us a quadruple across, but not quite. Where does 9 go in this row? There we go. It's not there. Well, for that reason, I was actually seeing the palindrome. It's not there because of that. We've pencil marked all these not to include a 9. It's not there because that's there. So actually 9 has been placeable in row 3 probably for a good long time. And that may have involved you shouting until you were puce in the face. Now, 7 and 8 have to be on this diagonal. 7 is there. 8's going to have to be in the central box. That has ruled 8 out of the blue cells because it can't be here. Now, it's also off the diagonal in this, off the other diagonal in this box now. But it could still be on it there. 2, 3, 5, 6, 8. I can't see it now. 7, 8 as a pair. How's that helping? 7, 8, 9. 9. 9 is off the diagonal in this box, and it's off the diagonal in this box. And it can't be there or there. So 9 on the diagonal now. I'm really not paying enough attention to 9s. Now 8 has to be here on the diagonal, and that is yellow. So yellow is done and is 8. Can take 8 out of a few cells. That gives me a 5, 6 pair. Purple becomes 3. I get 2 and 3 on the diagonal, which means that the rest is 2, 4, 6 up in this corner box. So these other 3 cells in that box are 1, 3, 5. That one can't be a 3, and that's on the diagonal. So that's 1 or 5. Let me colour those because I've still got some colours left over. And this digit has to appear here and is 5 or 6. So that becomes an 8. 8 in one of those 2 cells. Tempted to start colouring these 5s and 6s, but let's not do that yet. That's not an 8. That's not an 8. 8 in the central column is here. 4, 3, 8, 4, 9. One of these 2 is a 7. No, these are both from 2, 4, 6 or 7 for the middle box. That's forming all 3 parts of a quadruple. Where do 1 and 5 go then? Oh, that's become a 7 since we got the yellow 8. So that's not 7. So 7 is on this line, and therefore in one of these 2 cells, and that's not 7. So 7s are in a little tight 2 by 2 box there. But that could be on the diagonal or not. Oh, what about this now? If these were 6s, 12, 21, 1 there and 4 there. Oh, look at this one. Wakey, wakey. Right, that needs a 4 here because those 2 are going to add up to 7. Yeah, that's right. That's just stopped this being a 4, which I was looking at a second ago. So if those were 6s, 12, 21, you'd need 5 from those 2, and now this can't be a 4, that can't be done. So they're not 6s. Now, if they were 4s, 8, 17, then this would have to be 1, 8, because it can't be 5, 4. And if they're 2s, 4, 13, we need another 13. And again, this can't be a 1, it would be a 5, and this would have to be an 8. So that is an 8 either way round. That's a really pretty step. Whether those are 2s or 4s, given that that's 1 or 5, this ends up being an 8. That's very nice. So 8 there. Must be able to finish 8s by putting 1 in there. They're all done now. Actually, that is a right in 9. And there's a 9 in one of those 2 cells. Ooh, there's a 9 in one of those 2. So that's a 9-3 pair. That can't be 4 anymore since we got the 4 over here. What have we got left to go in the row? 2, 6 and 7. Now 4 is on that diagonal. Which actually hasn't added to any of my understanding of the puzzle. Never mind. 1, 8, 3, 9, 1, 7. Three, 2, 4, 7, 8. No, I'm not getting that. Oh, come on. Something must have happened. I'm sorry if you've spotted what's been freed up. Look at this digit. That's the same as that. So it's not the same as this. So those... Okay, that's not what I was coming up with. That's irrelevant. Sorry. I thought I was going to be able to make this a 5 or a 6, but I am probably talking nonsense. Yeah, I'm not sure that that is the case. So that's, oh, this 8 has gone on this diagonal, right. So if these were 7s, 21, 29, that would be a 2. If these are 6s, 12, 20, 27, this would be a 4, which it cannot be. So that is a 2. 7 is blue, that rhymes. Let's take out the 7 there. These are, that is 2, 7 is blue, and there's not much else left to do. 6, that becomes a 5 on the palindrome. We've got 2, 6 and 7 left. That's a 7 just by Sudoku from the blues. These aren't 7. 1, 3, 9 to go in here. That one can't be a 9. We can't have a 3 on the diagonal. 8, 7. So we've 2, 4 pair here. Now, which one of them is on the palindrome? I don't know yet. 6, 5 pair here. I do know which one of them is on the diagonal. 9 and 1. We get a 5 up here. That green has become a 1. Still haven't done red yet. That's a 9. Now, that makes that a 3, 2, 4 pair. So this is a 6. That fixes the rest of this positive diagonal. That 3, 5 pair looks down to the bottom. We get 1 and 3. Oh, the 4 is red now. There we go. That's all the colouring I was trying to do earlier. 2's on the palindrome there. That's a 4. 1 and 5 here must be able to be written in. That is the case. 6 there. This is a 2. 6, probably going to finish the puzzle and then check the last diagonal. 6 there. 3 and 6 in this column, and that fixes 3 and 5 in column 7, if I couldn't type them correctly. That's a 2. Here we go. That 10, 14, 18, 26, that has worked. So we have 7 and 5 to put in the box. We have a 6 to finish the column, a 2, and then this should be a 1, which finishes the row, the column, the box, and the diagonal, and makes the puzzle correct. So yo banana boy, that is the solution. Very entertaining. I like the way that the diagonals work together with those interesting palindromes. I'm not sure that it helped that there were more clones within the palindromes than usual. It did help. And that was good fun. So I hope you had a go at that one. That really was between quite approachable and fairly approachable, and enjoyed it. So thank you very much for watching as always. Hope to see you again soon on the channel. Bye for now.